Hello and welcome. We're trying a new thing in class where examples that I'm not able to finish in class I make available for you outside of class on a video. So this is our example from Wednesday. We're showing that the sum of integers from 1 to n can be calculated quickly as n times n plus 1 over 2, and that is true for all n greater than equal to 1. I'm going to show this by mathematical induction. We're going to start with the basis step. So the basis step, we want to show the theorem holds for the smallest possible n that we're trying to prove in the theorem, or we're trying to show that this is true for all n greater than or equal to 1. So 1 is the smallest n that can be. So we're just going to plug that in and just check the math and make sure it works. So the sum from I equals 1 to n, which we're plugging in 1, of I is just 1. There's only one term in that summation, and it's 1. Alright, and we're trying to check, does that equal 1 times 1 plus 1 over 2? So let's multiply that out. Does 1 equal 1 times 2 over 2? And that does equal 1. So that's not a question anymore. Those are equal. And our basis step is done. Okay, for the inductive step, we want to assume that this is true for some integer, some particular integer. We just don't know what it is. We're going to call it k. So we're going to assume the theorem is true. So it is true that the sum of I equals 1 to k of I is equal to k times k plus 1 over 2. So we're going to assume that is true for some integer k greater than or equal to 1. Alright. Using that assumption, what we want to show that this is true for k plus 1. So if we assume it's true for some number, we can show that it's true for the number right after that one. So we want to show, and I'm going to do this in red so we keep this highlighted. We want to show that the sum from 1 to k plus 1 of I equals k plus 1 times k plus 1 plus 1 over 2. That's our want to show. Alright, so we're going to start with what we have to work with here in our assumption. So we're assuming that so let's start with the left-hand side of our want to show. And we're going to try to see if we can come out with the right-hand side of the want to show. So starting here, we're going to say, okay, I equals 1 to k plus 1 of I. And we can't just write the right-hand side of the want to show, because that would be just assuming that what we want to show is true, and that's what we're trying to show. So we're just going to use the definition of summation to say, well, this is just 1 plus 2 plus 3 and dot 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 plus, and then as we start approaching k, we're going to have k minus 1 plus k plus, the very last term of this is going to be k plus 1. So this is just what a summation is. Definition of summation. Okay, now I wrote the terms 1, 2, and 3. It may be that 2 and 3 are not really there, because it could be that our k, it just is greater than or equal to 1. It could be k is 2. But we'll just write those out to kind of show what we're thinking. But I do want to make the point that we're not saying necessarily that 2 and 3 are in there, because they may not be. But okay, so what we can say though is that